hope prepared for class, so you already have this nice free textbook saved somewhere, right? The download it like that, and then you can also utilize the college. So you can use the notebook that I also got one because my computer is pretty old and it falls apart. So I got one as a backup, and it's pretty nice little device. I think it's just perfect, not too heavy to carry around. So I guess we're going to do a little bit of trigonometry today. And I'm going to start with the quiz exercise that we had last time. And that impressed me a lot because everybody did it right. And that's the way to go. So I got very happy because of that. Thank you for making me so happy. I really like when my students solve problems correctly, because that means that you're going to get a perfect grade. And that's my goal, to make sure that you all get very nice grade that you actually deserve. So I want to still do that little exercise just to refresh your memories on what we were working with. And that was first section of chapter 6 that I'm browsing through right now. And we only were dealing with degrees. I still remember you had a very good question about exercise, I believe 20, so I will do it after that. But let me first take a look at the quiz exercise number 27. I still have a few people on the list that didn't turn in the quiz exercise, and you should do it. You should turn it in. So minute is 60ths of degrees. So that's 9 minutes is 9/60. And then also we should add this, because and that was 9/3600, 3600ths of degree. So I'm going to need to plus these, not multiply, but add, because this is 9 degrees and means plus 9 minutes and so plus 9 seconds. So I go with the scientific calculator. So type in word scientific enables me to get to this favorite choice number 1 on Desmos. So I go ahead and put this numbers such as a 9 plus 9 divided by 60, and then plus 9 divided by, you should be careful. See, this calculator is good. It shows me if I enter in anything correctly or not. So this is 9 divided by 36 with 2 zeros. And the answer was 9 and little something. It was like 9.151525. So whichever way you put it down, it was okay with me. Some people rounded, some people did not. But I guess it doesn't really matter. You still get the answer, which is 9. It's 9 and a little something. So that was our quiz from last time. If you did not send me the quiz, then make sure something is sent to me, so I will definitely give you those points, because if you don't send me the exercise, then I can't give you credit for it, right? So send it to me, even if it's late. I understand things happen. The typhoon attacked us, right? So I know that some people panicked a lot. Well, now everything is clear and the weather is beautiful. So send me this exercise. So anyways, I just shared the link to the textbook. It's good that you're anxious to download it somewhere. So here it is. Just click on it and make sure it's saved so you can have it, and I hope enjoy it. So yeah, If you put the answer in the chat, that's it. I just had like 3 or 4 people in class that didn't send me the answer. You don't need to email it to me. If you put it in chat, I got it. And if you send it by email, I also get it. You don't have to do both. Some people say, oh, okay, I'm going to put it in the chat and in email, and also write it and stick it under the door of your office. You don't have to do that. Just Zoom chat is good enough. It's plenty, because I actually monitor it all the time. The only thing with this Zoom environment is that when you send me something in chat, especially at the end of class meeting when we have a quiz, there might be 10, 20 people ahead of you. So I get to your question eventually, so not right away, because if I got lots of questions, and I answer them and just one after another, little by little. So the message is, if you send me some question, well, you should just wait a little bit, because I'm getting to it. But usually if that's a question during the lecture, then I answer it pretty much right away. And that's good that you care. That's good that you are asking questions. That's the way to go. Because again, that's your class. So you want to learn something, right? So anyways, let me start talking about radians. I know last time I just talked about degrees, and now we're going to talk about so-called unit circle. Unit, because its radius is equal to 1. Let's say, Alex, this thing does not really look like a circle. Yeah, I need to practice. But anyways, let's hope that this is a circle, and the radius is 1. So if you think about it on the XY plane and set it into the origin, so the center of circle will be at point 0, 0, then radius 1 circle will intersect my axis at points 1. Let's say Alex here will be -1, and there will also be -1. Yes. So it turns out that now we can measure angles completely differently, not with degrees, with this radius, or other words, with radians. So if you recall that the so-called circumference of the circle is 2 pi multiplied by r. That's something that I guess we just need to remember. So 2 pi r, or if you're looking at the area of circle, it's pi r squared. Pi is 3.14. It's some little irrational number, and it's actually not just 314, it's 1, 5, and dot, dot, dot. So there's more in this. And that circle with radius 1 will have its circumference equal to 2 pi multiplied by 1, right? 2 pi r, so it'll be 2 pi times 1, or just 2 pi. So if I try to relate this to the angle, this angle will be 360 degrees, or a full rotation, right? So in terms of degrees, and at the same time, it's 2 pi in terms of the so-called radians. Let's see, so it's like 2 pi times r. Well, we call it radius or radiant. Let's say, why wouldn't they call it as radii? Well, they just came up with name radians, and they actually never write word radians. So if they measure angle with 2 times pi, or just with number 2, and then don't say that this is 2 degrees, it means it's 2 radians. In fact, if you notice that pi is 3.14, then 2 pi will be about 6.28, isn't it? So if you think of the circle, then 6 radians will be, or 6 radius. 1, 2, 3, 4, 5, 6, and a little assumption, which is 0.28, if you walk around this unit circle. So if you keep walking around the unit circle, then you're gonna go by 6 of its radii and a 0.28. So you're measuring angle in terms of radius of the circle. That's pretty unusual, I think. But it turns out it's convenient for graphing trigonometric functions. So this angle, for example, is measured as 1 radian. And I say, well, that's 6.28. That's not very convenient. And indeed, it is not. So what you can do is divide by 2. So come up with those other favorite measurements, such as a straight angle applied to the line, the straight line. So it's straight angle. So 180 degrees will be equivalent to pi. So degree, and that's a radian measure. So we should be able to convert degrees to radians and backwards, because degrees is something more intuitive, but the radians is what you're actually going to be working with. So we should be getting used to them again, because when you be dealing with graphing of functions with respect to the angles, then you don't want to put here degrees and here just regular units. So instead of using degrees, we have regular units on x-axis, and we have also radians on y-axis. So that way we have graphs with the same measurements along x and y-axis, and that's exactly what happens in mathematics. Maybe in physics, they like time and functions in terms of time, or in statistics, there's a probability, so various different measurements. But in mathematics, we want to have nx and y-axis both in terms of same units, so we don't want to have a degree. And that's the key idea why we have to do this kind of conversions. So we can see that if I look at the exercise 20, for example, and we have an angle with a negative sign in front, well, then it means that what you can do is get the angle produced in the clockwise direction, right? So let me make a picture of this here on the coordinate plane. And this angle is dealing with 2 pi divided by 3. So if I take the whole thing and break it into 3 pieces, so probably a full rotation broken into 3 pieces. So I'm going to get something like that in here. So one can say, if you divided 2 pi by 3, then you actually have divided 360, right, by 3, and you got 120. Notice that if that's 120 degrees, then I can take a look at the angle, which is twice that, right? Because that's just 2 pi over 3, 120 degrees, yes. So the angle will be going somehow like that, right? Along the starting from x-axis and going clockwise. So that's negative 120. So how can I produce this angle in terms of the radians? Well, exact same thing, and that'd be my 2 pi over 3, and with a negative sign, because with positive sign, 2 pi over 3 will be going the opposite direction, and notice it looks like totally different angles above. So exercise number 20 looks like they will like to divide by nice numbers because we have full rotation, 2 pi is 360 degrees. So I can divide this by 2, by 3, 360, right? 36. And by 4. So it looks like there are lots of little factors that we can utilize. So I can try another exercise here, like number 18. It was also pi over 3. Let's see how that's gonna look like. So now instead of dividing 2 pi by 3, I take 4 pi and divide by 3. I can say that 4 pi over 3 is going to be analogous to my previous 2 pi over 3, but doubled, right? So if I times this by 2, so I can utilize my previous picture, and instead of going clockwise, I will first of all go counterclockwise. But then I take angle 2 pi over 3 twice. And notice that I'm going to end up at the same exact terminal site. So when you say it looks like this 4 pi over 3 and negative 2 pi over 3 end up in the same place. And it does, even though they're not the same angle, one positive, the other is negative. But if you plot it on the XY plane, you end up with exact same position. And that's something that happens with description of trigonometric functions, because they have actually infinitely many values. You keep on rotating and you get again and again the same result or y coordinate, but x could be various values of x. So radians and degrees, please notice that again, they're not the same, because radian is a length along the circle, so I measure that distance. But degree is nothing but a measurement of this angle divided 360 by 360 degrees by little pieces, by 360 pieces, so full rotation by 360 pieces. Each piece is 1 degree, and then you see how many of these pieces fit in here. So this is not really radius, you could put it anywhere. It's a slight difference, but I just want you to realize they're not the same. That's why I would not write they're equal, even though people say pi is same as 180 degrees, but it actually corresponds to be precise. So we'll be getting used to this measurements today, and let me try some more exercises here. Maybe I can try exercise number 47. So we'll keep working on this same section today and maybe have a little quiz at the end, just like we did last time, because it was so good. I got very happy. So maybe I'll give you another quiz today. Again, same level of difficulty. So pi corresponds to 180. So looks like pi over 3 will mean that we have to divide 180 by 3, and that's how we get to degrees. So instead of pi, I put 180, basically, and vice versa. And this is 60. And turns out this is very popular angle in trigonometry. So if you take the right angle, like one produced by x and y axis, and break it into 3 equal pieces, and then take 2 of them, 30 and 30, that will exactly give you 60. And that's same as pi over 3. So I guess what we need to start to feel comfortable about is this radian measures that I think nicely correspond to degrees. So let's try something with denominator of 4. So it's negative pi over 4. So how is that going to look like? And of course, they don't expect you to graph all of them. They just say convert. But I think whenever you make picture, you get a intuition into this, because again, if I just replaced pi with 180 degrees and divide this by 4, then looks like it'd be negative 45. So I can take basically half of the angle down below, because this is negative, so we go clockwise. And here will be our angle, which is negative 45 degrees. So notice I should be placing the degrees symbol with those, because otherwise it means we have radians. So conversion, simply whenever you see pi, put 180 when you're done. Sometimes you can't divide, sometimes you can. Usually you will get nice numbers, the ones that you can divide with no problem. So there are also some calculator exercises here that you can do by, not by hand, because that'd be pretty annoying. So let me show you some of them. And they expect you to utilize scientific calculator, the one that I already used, or you can utilize any calculator that you like here. So let me try one of the exercises with some kind of not very nice number of degrees. So, for example, problem number 59. So, in this exercise, they say, how many radians is going to be in 17 degrees? Well, if I have that only statement that we care about today, correspondence of 180 to pi, then in order to get 1 degree, what I do is I divide both sides by 180, right? That's how I'm gonna get 1 degree here. So instead of 17 degrees, I could utilize this pi over 180. So remember last time to be precise, 17 is 17 times 1 degrees. So that's how you get 17 degrees. So instead of that 1 degree, I'm going to put pi over 180. And of course, this is something that I have to just input in my scientific calculator. So another calculator exercise, you put 17 pi over 180. So the question is, how can I get pi in this calculator? And turns out it's right here. So you just click on that pi and it will be with you. And then divide this by 180, and you will get some not very attractive looking decimal. In fact, that's infinite, because pi is irrational number. It doesn't stop at that whatever 9728. It just continues. So you can just put 2.967 ... I guess that's plenty. Let's say, what if I just say it's 0.3? Well, technically you could do it. I'm not going to downgrade for that. I understand that you know how to round, but if you put just 0.29, that may not be correct, because it's not correctly rounded, right? But actually, if you put point ... so ... then you'll be on the safe side. So if you put 29 ... so without doing the rounded. So I'm just saying how to put it correctly. I believe in the textbook at the end, they usually round it to, I think, 4 significant digits or something, but I'm not sure. But anyways, it wouldn't really matter to me as long as you did it right. So yes, I'm glad that you're all here. If you're getting to this class a little late, that's fine. Even if you can't get into the class at all, whatever reason, doesn't matter. Just check your email and watch the recording. And of course, do the quiz at the end of it and send me answer by email. Again, make sure you tell me that you're in trigonometry class. So using calculators, again, we can definitely do that if we have this free, nice little calculator, or you can use your own one. It is really up to you. So looks like there are also conversions backwards. So for example, if you have 66 exercise, you say 66, it doesn't matter, don't be afraid, it's just 66. So it says 0.75, they want to convert to degrees. So how would I be able to do that? Well, it looks like if we had this key equation here, let me maybe write it again so I have a little bit more room here. The point is you either divide by 180 or you multiply by 180. So what I'm trying to tell, I'm gonna write in a few seconds. So since 180 degrees is the same as pi, right? So we were able to get, I'm going to put equals, not worry about that. So I'm going to be able to get 1 degree if I divide by 180. But I also be able to get 1 radian if I divide both sides of this by letter pi, right? So it looks like we have the way to produce degrees from radians and radius from degrees. You either use 180 over pi or pi over 180, and that's how it goes. So if I try, say, problem number 66, then we can get the 0.75, which is radians, or times 1 radian. So I can say that this is same as 0.75 times, instead of 1 radian, I put this 180 over pi degrees, and that's it. So I already have degrees in here, and you definitely need to use a calculator for this as well, right? So let's do it, 0.75. Please notice it's 0.75 of radius, so it's close to the actual, what, radius is about a third of 180, so it's like 60, some more than that, somewhere around 60, right? So I go times 180, and then I divide by pi. When I say, Alex, why didn't you put symbol degrees? Well, we're going to get the answer in terms of degrees, so we getting that many degrees here. You see, 42.9, so it's about 43 degrees. So what I can do is just say 42.97 ... So again, the answers, if you have not nice number of degrees or radians, usually are some infinite decimals. So what's not nice number of radians? Well, that's multiples of 180, or fractions, like say 60 degrees or something like 45 degrees. So then you can nicely write this using pi, because otherwise, if you utilize this 3.14 on calculator, then your answer is always going to be approximate ... which means they're not exact. And that's why in the textbook, sometimes they say, give us exact answer and give us approximate, rounded to some nearest whatever decimal. So the exact values will be with this pi's. So let me show you this in the textbook. So whenever you have something that has letter pi with it, let's say here, pi over 2, that's exact. But if you going to, instead of pi, put 3.14 dot dot dot, you divide it by 2, you get something with dot dot dot, so that's approximate. But approximate enables you to actually better see how many degrees are here, because if someone tells you 0.75 radians, so how many degrees is that? Well, that's about 43 degrees, so you get better intuition rather than you say, okay, that's like the summation divided by pi. So no intuition. What this means, who knows? Anyways, what else is in this section? They actually using the formula that we already discussed a little bit in the next group of exercises. So maybe I'll do one of those because that brings us to word problem like problems. So you don't have to worry about them actually, but I can still do one because I think I like these exercises, but they may be a little bit less pleasant. So they say length of arc of a circle of radius r. So remember, circumference is 2 pi r, right? So they want you to deal with this formula, and now they want to plug various numbers into this formula, turns out. So they say, what about if you have angle 1/2 radian and the circumference, oh, that's actually, what is C? S is length of arc, that's 7. R is 10 meters. So what they actually want is the missing quantity, and what is the missing quantity in here? Well, looks like that's letter S. So they don't call it a C here. They decided to use S. Okay, whatever you like to call it doesn't really matter to us. So I need to find S out of the formula. So in exercise number 71, I just need to plug 2 numbers in, turns out, and that's it. As long as you have formula, right? So go 2 pi, and you multiply it by r, which is 7, which is 10 actually, but notice this is the circumference. Oh, I see, the circumference. But what if we just want to not to get a full rotation, but just the angle here? So how would I go about this? Well, I should be a little bit more careful. So if I want to pull out the
Progress.
little angle, then I'm going to need to, instead of 2 pi, get that angle so-called theta. So if 2 pi, that's a full rotation, but if that's a little different, like angle theta, that'd be a rotation that we need, and that's why it's a little s. Okay, now I guess we got what we need to utilize. Okay, so let us plug in 1/2 radian multiplied by the radius, which is 10, right? I'm doing an exercise number 71 right now. 10 is r, 1/2 radians is angle, and that's my arc length. So it's not the full rotation. So we take the radius 10 and we go by half of the radius. So we rotate it like that. And we rotate it by, looks like half of 10 is 5, right? Because it's half of 10. So no wonder we got this number. And this is it. That's the arc length S that we found. So it looks like it's pretty straightforward. Just multiply angle by the radius, and we got the answer. Notice if radius is bigger, the way along this arc will be bigger. If radius is smaller, it'd be smaller. So it is proportional to the radius. And that's the way to think of it. So it looks like in all of these exercises, it's pretty much the same story when you say, how about exercise from another group of problems? Okay. How did I get S equal to theta times R? Well, that's proportional. In fact, you can check out the formula, so you could get that formula. But that's a good question. If you start to think about this, then it's always going to go with respect to the proportions. So let me see. See, I going over these little formulas as we solve in exercises, and the formula utilized this here on the bottom. I try to highlight it a little bit better with this wiggly red circling. So I'm trying to find it here for you. Should be somewhere around. Let's see. So where is it? This was area. Where's this? Was circumference? That's angular. And where is it? Anyways, I guess instead of looking for it, I better give you analogy so you get a little bit better feeling about this, because they have it somewhere. I just can't see it right away. Just wanted to make sure. Oh, here it is. Here it is. They actually put R theta. So let me get a little bit more intuition into this, because I understand this is not obvious, definitely. So you multiply the radius by the angle in terms of radians, because if you multiply it by angle in terms of degrees, it's not going to make sense, because the answer be in terms of degrees, and we have answers always in terms of just numbers, not in terms of degrees for this. So they actually have here analogies. So if you look again at formula circumference of the circle, which is 2 pi times r, I guess that's where one could start. So if you have 2 pi is angle, and you multiply it by radius, right? In other words, if you have a little circle, like we have in the picture, its circumference will be much smaller compared to the big circle, right? Why? Well, because we have here little radius, some smaller number than the radius for the big guy. But notice that angle stays the same. For circles, the circumference, if you walk around the circle, the way around is called circumference, just like perimeter, but we call it circumference. It's going to be 2 pi angle. But we rotate by the same angle, but depending on the radius, we have different numbers. So let's say if radius is twice bigger, then we're going to have our circumference proportionally bigger, right? So now, if you don't take the full rotation, so if you care only about this measure, which is called arc, so not the full rotation, but the portion. And if I call it as arc equal to, let's say, letter S, that's how they distinguish circumference with the arc length. So they use letter S. Well, then turns out, again, if we have the angle here measured as theta, they like Greek letters for some reason in trigonometry. So if you put, instead of angle 2 pi, angle theta, well, similarly, it'll be theta times that radius. In fact, what I was talking about is measurement radiant measure of angles. Remember, I was saying, what if you take radius equal to 1, the unit circle? Then in order to measure the angle of radius 1, I need to see how many radii are here. So if you walk around 1, so same as much, and produce that arc, notice that this is going to be exactly called angle measured 1 radian. So to say it again, 1, what do you mean? Well, this is your radius, right? 1. So if you walk along the circle same as much as your radius is, that's defined as a 1 radian. And that's analogous to what we have here. So if you multiply your radius 1 by the angle theta, you just get your angle theta, right? So if you happen to have theta equal to 1, then you're going to have 1 radian arc length, and that should be put as S, arc length. So this is worth to think about, because this is not obvious, this is definition. So that's how we define radians, and that's why we have this kind of interesting questions. So I'm not gonna continue with these little formulas because they just formulas, they're pretty straightforward, but they are related to mechanics, and I'm not going to get much into them, into the mechanics. Don't try to get this on the tests, but if someone is interested, you could look at the other little formulas they have here in the section and try to do some problems if you want to. Again, I'm not gonna ask you for that on the tests, because I know it's something that people need to get used to. And actually, we'll be getting used to this throughout the whole semester. And that's why, in my opinion, this story should have been in the textbook a little bit later. So they should have stopped at this stage. And then when we get used to more and more these ideas of measure an angle in terms of radius, so that radian measure, and then we'll be able to actually have better feeling of what's going on, because otherwise it's a little bit too much for the very first section that we just encountered. So I'd like to do another exercise and then have you try one very similar, and I will do the problems nicer, the ones that we actually need to do for this class, and that'd be some kind of exercises similar to turning degrees into radians and vice versa. So let me try, for example, something like 48, 5 pi over 6. So how can I turn this into degrees? So 5 pi divided by 6, we already know that instead of pi, I can utilize 180 degrees. So I put 5 times 180 over 6. And now it's 180 degrees over 6. So I divide this and get 30. So 5 times 30 is 150. So you should put in the chat 150. I know you can't put degrees. You need to, well, get some sophisticated tricks, and I don't expect you to do this. So if you just put 150, I will know that this is in degrees anyways. So how about if you try for a quiz number 47? Again, if you are not sure how to do this, you can think of it and email me your answer later tonight or tomorrow or whenever. But advice is just replace pi with 180. And this way you will be able to get number of degrees right away. and send it only to my name and Zoom. And that's all we need for today. After that, you can log out and enjoy the rest of the night. So we'll continue, we'll move to the next section on Thursday. So we're solving exercise number 47. I tried to put it in this nice little box. So exercise number 47 is our quiz. So how many degrees is that? One of future favorite exercises. Don't hurry, but try to do your best to get this conversion. So I'm going to stop recording this. And as usual, I will email you this recording a little later.